Welcome to the third panel of the Schiller Institute International Conference, The World on the Brink, for a New Piece of Westphalia. And this third panel is dedicated to science. The headline, the title of the panel is The Implications of the Scientific Revolution Underway. So you just heard a musical offering, a Handel violin sonata, a movement from a second movement from the sonata in D major, which was played by Jung van Joon at the violin and by Dura Yun at the piano. This was a performance in the context of a concert given by the Schiller Institute, New York City Schiller Institute Chorus on December 15, 2022. And now let me introduce the panel with a short video by Lyndon LaRouche in the year 2012, where Lynn speaks about what the real approach of man versus the environment should be. This is very important, especially in the context of the discussion today about environment and climate, things which are confused, but also are run by a power structure in an unscientific way. So Lynn gives the real approach to these issues. Let's watch the video.
In the population generally, the level of creativity has dropped. The people are becoming more and more bestial in the sense of their lack of creativity. You have a certain minimal amount of creativity going on in some cases, but it's not sufficient even to maintain equilibrium per capita on this planet. So the problem I'm addressing is specifically is not only is creativity, as we've discussed it here on the table, is it not an urgent matter for humanity? All policy, all political policy of sane nations is going to be based on consideration of the principle of creativity. That's anti-entropic creativity. And we are far behind that now. We're on the road to doom if we don't reverse it. But it's another factor. Where's the source of creativity? Well, the source of creativity of the type we need is radiated by mankind. But the number of people who are creative, actively creative, even personally, in their own personal development, in the United States, for example, is declining. We are a declining self-doomed nation because we are anti-creative. Look at what we've done to our people. Look at the number of people who have worthless jobs. Look at the number of people who are employed or receive their income in speculation, financial speculation. They are producing nothing. They're negative in their effect on creativity. They are dooming society by their very increase of their very numbers. You know? The British Empire, the British monarchy is not helping this process any bit. So therefore, the problem is that there's a reduction, an accelerated reduction, since the assassination of Kennedy in particular, and also since actually the rate of creativity under Franklin Roosevelt in our war mobilization, for example, was higher. And Kennedy was simply going back to that kind of rate of creativity that we saw during the war, in the mobilization for the war. So now we've come to a point where the shrinking of the number of people who are actually in a sense of anti-entropy, creative, is collapsing. Is collapsing as a matter of government policy. But the other problem is the lack of a rise in creativity per capita in the population and in the effective overall rate of creativity. In other words, you take the curve, you close these things, and we say we have to take this Cenozoic rate. We have to accelerate that. And the way we can accelerate, the only way we can accelerate it, is by increasing the ratio and quality of creativity induced in the education and development of our people. What we have now in the Green program is actually the doom of humanity. And anyone who's a greenie essentially is implicitly a war criminal, or the same thing. They're killing humanity by destroying the thing that humanity depends upon, which is not only an increase in the number of people who are creative, as opposed to people who follow routines, or do useless things like Wall Street. But we're also failing to increase and advance the quality of creativity which these people are capable of doing. So our educational system is actually a mass murderous system, because what is being done to education is diminishing so much the ability to generate creativity that net loss would already doom us at a slower rate than Obama would do it. And that's what's in process. So therefore, we have to understand we can no longer tolerate the oligarchical system under which the great mass of the human population is left ignorant of these kinds of qualities of discovery which are needed for humanity. And we are, in a sense, comparable to the dinosaurs in the way our public policy is followed. By leveling off and reducing the rate of productivity in our population on this planet, or large parts of the planet, especially the transatlantic region, we are actually condemning the human species insofar as it accepts this policy to extinction. So we're at an extinction point, which is coming up at us fast, as long as this green policy is maintained.
(2012). And now let me introduce Professor Mark McMenamin. This is a little change to the program we have, hello Professor, to the program which we have published, but Professor McMenamin has to speak first because afterwards he has to leave us. So let me briefly introduce him. He's a geologist and a paleontologist from the Department of Geology at Mount Holyoke College in the United States. And the professor will tell us about the not so boring billion, Rodinia and the origin of animals. Please, Professor.
Thank you. Do you hear my audio?
Yes, very good.
Okay. Can you co-host me for putting up my slides? Okay, great. Thank you. Okay, thank you for inviting me to speak. And let me put my slides up right away here. Yeah. There. Are you seeing that shared? Yes. Very good. Here we go. Okay, so my talk is the not so boring billion, Rodinia, and the origin of animals. So I'm going to be taking you through a paleontological mystery and a paleontological controversy that relates to the appearance of complex life on this planet, which has been the primary focus of my research over the years. Okay, so what is the boring billion? Here is a timeline of signature events on the planet. And we see that the boring billion, supposedly boring billion, occurs between 1.8 and 0.8 a billion years ago during the Proterozoic. And that during this time, it's thought that really there's not much going on in Earth history, because the first animals don't appear until after the boring billion, and the first eukaryotes have already appeared. And so it's thought to be this boring period, but I'm going to try to convince you that there's interesting things going on during the boring billion. I noticed that it is bracketed by two supercontinents, Nuna here at the beginning and Rodinia here at the beginning, and Rodinia undergoes an assembly and a breakup. Okay, so here is the Rodinia supercontinent, and this is the oldest well-characterized continent in Earth history. And this continent needed a name in the 1980s, so Diana and I named it Rodinia. And in doing so, we used the Russian word Rodina, which means homeland, to make this our original homeland. And indeed, there's evidence to suggest indeed that the shores of this supercontinent were where our most ancient, advanced, complex life animals, ancestors evolved. The red dots here on this diagram show granite bodies that formed between about 1.3 and 1.5 billion years ago. And the green shows the 1.1 billion year old, GA is billion, mountain belts that were associated with the continental collisions that led to the formation of the Rodinia supercontinent about 1 billion years ago. Okay, now to the paleontology. Here we see the fossil, a mysterious fossil. It's known as Paleodiction, and it's thought to be a burrow structure that's made by an animal that burrows into the sediment to form this hexagonal pattern, but nobody knows what made this interesting pattern. This is a turbidite that was, or rather a burrow, a Paleodiction burrow that was sand casted when sand fell into the burrow and allowed it to be preserved. Okay, here is Hans Lugensland's 3D reconstruction of what the burrow system looks like. Not only does it have these hexagonal rings, but also has these vertical tubes as part of it as well. And so this is Lugensland's reconstruction of this. Now, the most interesting thing about Paleodiction is that whatever's making it is still alive today. And here is the top of the structure in the deep sea floor, thousands of meters below the surface. Here is an image taken from a submersible. There's a 10-centimeter laser beam separation. And so this is the structure still being formed on the seafloor, but we have no idea what animal is making this, if indeed it is an animal, and other theories have been proposed, such that it's some kind of protist or giant microorganism. I believe, though, that it is a burrow that is made by an animal. So we're going to try to figure out what this creature is. It has a very long fossil record and is still alive today, but we do not know what the creature is that's making this structure. Submersibles have actually sampled these structures in the deep sea mud, brought it onto shipboard, but there's nothing inside of it. It's just the burrow pattern. There's no animal inside of it. Okay, so that's the first problem that I wanted to mention. The second, and that's the Paleodiction problem. The second problem is the bath sponge problem, or the keratose sponge problem. Keratose sponges are a type of sponge that has a non-mineralized spicule, and so it's a flexible spicule, somewhat similar to Spongia officinalis, the bath sponge that's harvested for use in bathing. So there's a problem with the study of keratose sponges, or putative keratose sponges, in geology, and it's thought that, or some researchers think that many different types of limestones or other types of carbonate rocks are filled with the remains of keratose sponges. My co-authors and I published in Sedimentology a scrutiny of this particular theory, and we challenged the keratose sponge interpretation, which we thought was being applied in too many situations where it did not apply. So the subtitle of our paper is A Problem of Interpretation. We tried to correct this interpretation. Okay, so we then have now two linked problems. The first one is, what is that Paleodiction structure, the hexagonal structure? And problem two is, do keratose sponges actually occur in all these limestones? And some of them are going back to 1 billion years. And I believe that these two questions are linked. Furthermore, they directly relate to our efforts to understand the antiquity of animals. And the solutions will involve the analysis of pellets, which are microcoprolites or tiny fossil feces, and their relationship to vermiform microstructures, which I interpret here as ancient micro burrows. So let's take a look at both of these, the pellets and the tiny burrows. Okay, now here are some results from my fieldwork in Mexico. And these are early Cambrian microburrow nests. And on the left here, you see one of these nests, and these line structures running through it are tiny burrows of animals that were digging into the lime mud. And then over on the right here, we see another one of these nests that is formed inside of the cavity of a coral-like creature called an archaeocyath that had fallen over on its side. And then these burrowers developed their nest inside of the central cavity of this creature. Here we see a pellet nest association. On the left, we see, again, from these carbonates in Western North America, we see pellets here in the upper part of the left image that have then become a burrow system here. So the pellets have disaggregated, and then animals have begun burrowing through them. In the image on the right, we see serial reoccupation of the same cryptic cavity or space with an older burrow system. You can still see the burrows in it, but it's been somewhat recrystallized. And then a newer burrow system that was developed right on top of it. And the black arrow shows the transition between the old burrow and the new burrow. So we have evidence here for serial nest reoccupation. Now, the creature that's doing this became the subject of an operetta that I wrote. Speaking of creativity, this is the operetta called Trilobite Jury. And so I wrote an anthem for the creature that was digging these burrows. And I'm going to play that for you right now. Here we go. Are you getting that audio? Yes. Hold on. Okay, I think I have to stop share. Okay, then I'm going to share. Share. Okay, here we are. Let's try that again. Okay, hold on. Whoop. Here we are. 1 second. Pull this up a little. There we go. Okay, here we go. Here is Maternia. Actually, let me try that again. Okay, here's Trilobite Jury. Here are all the score pieces and a few other things for Trilobite Jury. You're welcome to take a look at those. All right, here is Maternia. I'm trying to start it over. Are you getting that audio? Oh, original sound. Okay, hold on. I will get original sound. Okay. Hold on 1 second. Let me just put that off. Okay, let me pull up the original sound. Escape. Okay, hold on. Here we go. Ah, there it is. Okay. Do you have that audio? No, it's not coming through. Okay, hold on. Let me try something. Okay, let me try one more thing here. So Zoom. Okay, I'm going to share. Nope. Let's see. There we go. 1 second. Okay, here we go. Let's try this. Is that coming through? No. Is that going? Okay, good. Okay, so that was just one of the scores in Trial by Jury. Thank you. And you're welcome to explore the rest of that score. It is most of the score pieces are up on YouTube. Just go to my YouTube channel if you want to hear more of that music. It's basically paleontology set to music, and I hope you enjoy it if you want to partake of more of that. Okay, so I'm going to return now to our talk. Here we go. All right, very good. Okay, here we are. Okay, so now continuing about these paleontological mysteries. Let's see, right, first slide. Okay, now here is a very important discovery that was made in Canada by Elizabeth Turner, who found these sort of squirmy looking structures in limestone that was 890 million years old. And Turner interpreted these as the keratos sponges, the bath sponges. But when my students and I were looking at this research, we noticed that the structures are somewhat collapsed towards the bottom, and also you get a second layer here. You seem to have reoccupation of a zone of lime mud that then is filled with these burrows. So we reinterpreted this as the micro burrows rather than the flexible organic spicules of a bath sponge. So this then represents a new interpretation of these things. And if we're correct, and I believe we are, then this means that complex animals able to make a burrow, are very ancient indeed. They go back 890, getting close to 1 billion years of age. This is a very interesting reinterpretation here. So we have to be careful, though, because you can get burrow-like structures from abiotic processes. So here we see differential compaction in flour that's forming what looks like it could have been interpreted as a burrow-like a structure, but no flower beetles got into this flower. This was just an example of differential compaction, leaving spaces between clumps. So we have to be careful that we're not dealing with phenomena such as Ostwald ripening and so forth when we're making these interpretations. So we have to proceed with caution. That said, I began to find more of these micro burrows throughout the rock record. This is a geological thin section from the Cambrian, the late Cambrian period, from a very famous site near Saratoga Springs, New York, USA, called the Herkimer locality, which is known for its layered structures known as stromatolites, but most especially known for the Herkimer diamonds, which I'll show you in a moment. Now, in these limestones, you see this Y-shaped structure here in the left slide, and then under cross polarization, it becomes very colorful. Those are quartz sand grains, and the only way that those quartz sand grains have gotten in there is by some kind of animal forming a burrow and then pushing those grains into it. And we see a large Y-shaped burrow. There's a medium-sized one in this layer here, and then lots of little burrows similar to those that Elizabeth Turner was seeing in the very ancient Canadian rocks. These Cambrian ones are, of course, much later in geohistory. Okay, now here is the slab of rock from which that thin section was taken, and this locality is known both for the famous Herkimer diamonds, which are not actually diamonds, but they're doubly terminated quartz crystals of gem quality, which are mined at this site. And also at this site are these structures called stromatolites. And these are layered structures formed by biofilms or biomats that grow upwards towards the light and form layer upon layer of limestone. These are known throughout Precambrian time as some of the earliest evidence for life. And I really won't believe life on other planets until I see stromatolites from other planets. Okay, now this particular stromatolite is interesting because if you look at the yellow arrow, the tip of the yellow arrow points out an anchor-shaped structure, which is a cryptic cavity between the cryptozoan stromatolite domes. And this, if we zoom in on this cryptic cavity, we see something interesting. Oh, look at this. Here is the cryptic cavity in the cryptozoan stromatolite. And you have this anchor-shaped structure on the left. And if we zoom in on the right, we see those pellets, those little microcoprolites are packed into this space, very similar to the earlier Cambrian situation in Mexico. So we have evidence here for pellet packing in this cryptic space. Here's a diagram of what's going on here. Here we have the stromatolitic domes here and here, and then this space developed here, and some kind of animal went down and packed this full of pellets. I believe then that this is evidence for a microburrow nest that has been packed with organic rich pellets, which will be used to provision the juveniles when they hatch in this protected space. Okay, now if we look at the fossil record, this kind of situation is found throughout the fossil record. These are shells of gastropods and other types of fossil creatures, and the insides of the shells are packed with all these pellets. Look at in B here from Toom et al. Those pellets look just like the ones in the stromatolite. And then if we look at C, we see they're also associated with burrowing, forming a sort of geometrical pattern. So I see this link here between the pellets and the geometrical burrows that somewhat resemble a paleodiction. Okay, here from fieldwork that I completed in Nevada at Berlin Ichthyosaur State Park, we found a nautiloid fossil here. Here's a spiral nautiloid, basically an ancient relative of the pearly nautilus. And in the sediment that had gotten inside of its gas chambers, you see this same development of the burrow system. Really quite interesting. Here's a sketch of this. And so the septal chamber sediment has this geometrical patterned burrowing in it. Very interesting connection. And there are also many nautiloid fossils that have the pellets packed inside of them also. Okay, so now here is a very critical image. And this is from work by Dolf Seilacher and Peter Rona. And here we see the paleodiction pattern associated with the pellets. And I believe that these pellets here over on the right side of the image represent the microcoprolites. And so I think, once again, what we see here is a connection between the microcoprolites that are being used for food and the burrow system itself, which is being used as a nursery for the tiny animals that are being nurtured in this sheltered space, in this case, dug into the mud. This is still happening on the seafloor today. And every time that our researchers sample these, they find no animals because the babies have grown up. They've left the nest. We're finding empty nests on the seafloor. We've never captured it with the animal inside. So my conclusions then are as follows. The recognition of fossil animal microburrows extends the fossil record of advanced animals back to getting close to 1 billion years ago. And this is consistent with a report that was basically ignored by Robbins et al. In 1985 of microcoprolites in nearly billion-year-old strata from the Beish group in Saudi Arabia. Microburrows and pellets occur together in early Cambrian microburrow nests in Mexico in the earliest ancient reefs, as I mentioned. Therefore, we might interpret then Paleodictyon, that geometrical trace fossil, as a type of pellet geometry burrow community that has left the cryptic space. It is free living in a sense and is formed outside of cryptic cavities and shell interiors and is now able to form in the seafloor mud without having to have a shell nearby. And the image here is Robbins's 1985 image of these pellets that she and her co-workers were detecting in these very ancient rocks going back into deep Proterozoic time. That concludes my talk. Thank you very much for listening. I'd be happy to take any questions.
Thank you, Professor. Thank you, Professor McMenamin. How long can you stay with us?
I can stay about another 10 minutes.
Okay, great. For those who just connected, we are at the third session of the Schiller Institute International Conference, The World on the Brink for a New Piece of Westphalia. And we just heard Professor McMenamin, who is a geologist and paleontologist at the Department of Geology at Mount Holyoke College in the United States. And now we have 10 minutes, about 10 minutes for questions. Let me see if I got some questions here. Well, there was a question by one of our viewers, which was then answered in the chat. Maybe you want to add something. The question is, what is differential compaction? And then since there are no other questions yet, I have one question, Professor. I read that you have an hypothesis on Hannibal crossing the Alps,
Yes.
which I'm very interested in because it's not the usual version, and it's relevant because of the whole discussion on climate, on what the temperature was at that time, etc. So these are the two questions.
Very good. With regard to differential compaction, when sediments are transformed into sedimentary rocks, there's a process of compaction. And with, for example, a mud rock, which would turn into a shale, the compaction is 40%. So the mud will be this thick, the rock will be only this thick. And that's because water will be pressed out of the spaces between the sediment grains and so forth. And we know that processes like this occur in limestones, but they're not well understood. A student of mine last academic year went out to Michigan and brought back a coral head that had been squished in a very strange sort of way. And we still can't understand why it has that particular shape and why it was deformed in that particular way. And we're trying to understand the processes that lead to the formation of particular types of lime muds turning into a substance called micrite. And this becomes a component of the limestone. And it behaves in some unusual ways, and the rocks get compressed, but there are strange processes associated with this compression. Some parts will compress more than others. That would be the differential compaction. And so we're trying to learn more about these processes in order to allow us to interpret what I'm calling the microburrows and the pellets from the Earth's past. So it really is kind of a material science problem as we try to interpret these structures that we see in these ancient limestones. And the group that I worked on in the sedimentology paper, we've also been working separately on these New York stromatolites, and we all agree these are the most complicated rocks in all of Earth history. There's just so much going on in them. It requires a lot of discernment to figure out exactly what process led to the various features that we're seeing in these rocks. And I think part of that, the reason for that complexity is that animals had gotten into these stromatolites and began to change their internal properties. So you get a transition from a stromatolite to a clotted structure called a or a thrombolite, rather. Okay, now to the second question about Hannibal's crossing of the Alps. A very, very interesting question. The Carthaginians there's a lot that we don't know about them. Most of their literature was lost or destroyed in the Punic Wars. We have a few tantalizing scraps like the Periplus of Hanno, which recounts an amazing trip along the coast of West Africa. There's also Pharaoh Necho's Phoenicians who claim to have circumnavigated Africa long, long ago. So there's really some very interesting things about these people that we don't fully understand. The Carthaginians put together the first multinational army that participated in a world war during the Punic Wars. And then when Hannibal sweeps down out of the Alps to attack the Romans, that's a fantastic story. And clearly there was some knowledge about how to get through the icy regions in the Alps to launch this surprise attack with the Carthaginians, who are thought of as a southern people, launching an attack from the north very unexpectedly, part of the brilliance of Hannibal as a military commander. There's a lot we would like to know about that particular event, because I think it was a bellwether or precursor of many of the conflicts that were to follow. So in some ways, the Punic Wars were the First World War.
Okay, I have another question for you, and maybe two. The first question is, can you explain the relationship between your musical composition and your scientific research? And maybe I have another question. Just let me look into my mail.
Yes.
Yes, I have another question.
Mm-hmm.
Have you seen any relevance of the discoveries now coming to us on the astronomical level from Webb telescope et al. And others, and your discoveries? That is, connection between the extreme micro and extreme macro. That was the second question.
Okay, those are great questions. Okay, the first question, with my musical compositions and the science, the paleontology. Well, I put this together because I've been acting with a local theater troupe, Valley Light Opera, and they do Gilbert and Sullivan presentations. We've done Pirates of Penzance, Iolanthe, Yeoman of the Guard, and I was kind of inspired by that to write my own paleontology operetta in the style of Gilbert and Sullivan. And also, I was thinking of, as I am a college teacher, I thought that this would be fun for the students to see the paleontology that they're learning about put to music. And it's been very effective in the classroom. The students, I play the entire trial by jury video for them. That video, by the way, was made during COVID lockdown. The theater troupe was very bored because they couldn't perform. So I wrote the operetta, and then we did it as a webinar and recorded it as a webinar. So that's available on the internet. You can see that. Unfortunately, it does not have the music because I hadn't finished the score yet. So right now the music exists as a YouTube and audio files, and there is a non-musical webinar performance, but we haven't had a full production of Trilobite Jury yet. I'm still waiting for someone who's interested to do that, to give us a full production with costumes and everything of Trilobite Jury. It's been very effective in the classroom. The students really remember what a hyolith is. They remember what a microburrow nest is after they've done both the science in the classroom and the music. So it puts together a unique type of pedagogy. Now to the other question about macro connecting to micro cosmic kinds of considerations. Well, I think this is really very important because a lot of the same patterns and processes are from differential compaction to the patterns and surfaces that we'll see like pingos in areas of glaciation, to the kinds of surfaces and textures that we're going to be and are seeing with our remote imagery on planetary and moon surfaces. These things are all very connected, and as living creatures, we're very much in touch with patterns and pattern recognition and pattern creation. There's that creativity that we were talking about. The creativity of life is really taking these patterns and then making things with them. So with the Maternia creature, finding a hidden space, a niche somewhere that then she's able to rear her young in this space. That's because of a spatial orientation of a way of finding something physical and then turning it into the biological. So I think there are great connections here with understanding the patterns around us, and then the creativity that we use to extend and exploit those patterns as we create them, find them, and use them. Okay, I have to go.
Okay.
So
I'm sorry, I have one more question, but we will send them to you then.
Okay, I will be happy to answer any questions that you send to me, and I wish you a splendid continuation of the conference. Thank you for inviting me.
Thank you. That was a great presentation, Professor.
You're welcome. See you later.
See you.
Bye.
So, for those who just connected, we are at the third panel of the International Conference of the Schiller Institute, The World on the Brink for a New Piece of Westphalia, and we are discussing science. Now, the third speaker on our panel, actually the second speaker on our panel, is Francois Mellet, who is an industrial engineer from South Africa. He is director of operations at Stratek Global in South Africa, and he will speak about nuclear energy, and especially about the new kind of reactor, the high temperature modular reactor, HTMR, as a power solution for the developing world. Please, Dr. Mellet. You probably are muted, Dr. Mellet. You have to unmute yourself. We can't hear you.
Okay, thank you.
Oh, ahead, please. Go ahead.
All right, I just want to share the screen. Right, is the screen full yet? There we are. Right, good afternoon, everyone, and thank you for the opportunity to share with you the HTMR 100 this afternoon. I'm speaking from South Africa, And in South Africa, we have Father's Day today. So for those around the world who have Father's Day today, well, I hope you have a happy Father's Day today. When we talk about South Africa and our nuclear experience, basically we started the Atomic Energy Act in 1948 to regulate the uranium industry. And we then started the first Safari reactor in 1965 to produce basically medical isotopes and do some other research. And to this day, we are exporting to about 70 countries worldwide these medical isotopes for health purposes. We also started the Koeberg Nuclear Power Station, which started operation in 1984. And I'm glad to say that I've been an engineer on this site from 1983. And I was involved with the last construction and then the commissioning of these two units. And I was over there for practically 10 years before I left for other power stations. The program I want to share with you is basically just talking about the SMR introduction, what the word small modular reactor means. We're going to talk about our power plant, we'll talk about the company, and then potentially the clients that we're focusing on. The SMR itself, on the left, the type that we're normally talking about is a system whereby you have a reactor. In this case, it's one that is fed with particular balls, uranium balls, and which we call trisofuel, and it drives a turbine in various ways. When we talk about a small modular reactor, we're obviously talking something that can be transported quite easily, assembled as a modular unit, typically like a container size. And there's a lot associated with this particular small modular reactor. Firstly, the definition caters for something below 300 megawatts electrical output. I just want to move this to the bottom. That many units may comprise a nuclear power plant, that it is fabricated in a factory very much like you manufacture motor cars, in other words, a production line. We're talking about shorter construction times. We know that we've had failures on a number of the large units worldwide in terms of time, in terms of budget, and we're trying to control that back to get it to shorter time frames within budget and within the time that has been allocated. There's the economies of scale, in other words, mass production of particular items. We can slot it into existing sites, in other words, retired coal or nuclear power stations, or in many cases onto mines or a harbor or a municipality. There's a big shift away from government-led to private sector business. And when we talk about the type of energy, today it is classified in the EU as green energy, nuclear in general, because it produces about 12 grams of CO2 per kilowatt hour. And we know that green power today is below 50 grams per kilowatt hour. With these small modular reactors, we have a high level of passive or inherent safety as opposed to the larger units. The safety heat removal in the case of an accident is not needed in small reactors because we use the water circulation, the natural circulation, and the design of the fuel and the reactor as its safety means. So we don't need any external safety injection or power supplies or things of this nature. The emergency plan is reduced to about 300-meter radius around the plant compared to about 5 to 16 kilometers on the larger units. When we look further, and we talk about the deployment of passive safety, that is a big advantage. And one of the things in our particular design is that we don't need large bodies of cooling water. And we'll talk a bit about that later. Just one thing to remember quite clearly is that there is under the SMRs 2 categories of SMRs. It's a Gen 3 Plus and then the Gen 4. Gen 3 Plus operates below about 350 degrees. And in many cases, these SMRs are just miniature versions of the large types, or in some cases, even instead of 3 steam generators, they just have 1 steam generator, reducing the power by a third to come in under the 300 megawatt sizing. When you talk Gen 4, we're talking then temperatures above 350 degrees, even up to 940 degrees. So you talk high temperature, higher efficiency, and obviously it can be used a lot for process heat, but you need completely different materials and a different fuel to operate the Gen 4 reactor as a difference. Sorry. We're going too fast. So our power plant, the HTMR 100, is obviously the one I'm going to focus on. From that point of view, we are talking about power, which is now available 24 hours, 7 days a week, 365 days a year. We have a refueling online, which typically allows the unit to run for several years. Typically, we can run on a batch of fuel for about 2.4 years before we need to start refueling online. Obviously, there's the turbine side or the other equipment that needs to be maintained, and you might even shut down for that reason. We based it on the original pebble bed modular reactor, which was somewhere in the region of about 160 megawatts. But it also used a cycle, which is helium, to cool the reactor and then drive the turbine from there. Our design is a bit different. We dropped the temperature from 940 degrees to 750 degrees output, and we added the steam generator with a normal steam cycle from the heat exchanger or steam generator to the turbine. This is in a case where we're producing electrical power. Operating at 750 degrees C obviously has certain advantages in terms of the materials, and you can then work with more normal type of metals than with the higher temperatures. We are obviously looking at a first of a kind. We need to prove it. The fuel that we would use in this reactor is pebble fuel and is graphite moderated within the core, but also in the fuel, and I'll show you some of that a bit later. We produce from this 750 degrees within the steam generator high quality steam, driving a turbine set of 35 megawatts of electrical power. So you may ask me, why is it a HTMR 100? Because that is 100 megawatts thermal energy, which can be used in process heat. So the most effective way to actually use this reactor's heat is actually in processes like paper or even in smelters or the like. It's also suitable to provide steam for process heat in these factories or for desalination, or also to fabricate pink or green hydrogen, whatever your choice is, because normally from nuclear it's pink, but we also term it green. Some people actually want to use it for producing ammonia, for fertilizers, etc. In our case, the basic nuclear design engineering is complete, and we're moving now on to the final design. The size of the reactor and the fuel cycle obviously was chosen on a reduced size from the typical PBMR conditions in Africa and wherever, where there's not a large body of water. Typically, we are going to use here cooling, which is radiator type of cooling, much like you have in a car with a fan and water circulating, rather than using a river or the sea or whatever. And this is for arid conditions, typically. The continuous production is obviously sorted by the online fuel loading system, which measures the fuel and the condition of it. And like I said, no large body of water is required. Furthermore, this particular reactor can burn uranium, plutonium, or even thorium nuclear fuel. This is just a glimpse of what it would look as a normal type of power station. But if we continue on, you'll see that this type of design is typically as we see it looking in a typical rural one-unit condition. You might just note that the reactor here is only 1/3 above ground and 2/3 underground. It is also a large vault underground for the storage of the used TRISO fuel, and we can store up to 40 years in this particular case. So what about the team? Our team consists of Dr. Kelvin Kem, who's been involved with the Schiller Institute over many years, Francois, who's our Director of Finances, LaRouche, who's our Director of International Affairs, operating from France, and then myself. We are based in Pretoria, with offices in France and also in New South Wales in Australia. It was founded for international marketing, fundraising, and the technological development. And we also have licensing agreements with other companies called STL and Resonant, Newtech, here in Pretoria. And our nuclear knowledge actually dates back to the 1980s with the Kuiberg and what we call today NEXA development, which is the body in South Africa that's associated with nuclear energy and waste storage. So the objective of meeting this increased global demand for small modular reactors is what we have in mind. And we have this capability to now perform these cost-effective services. As you know, it's the dawn of the nuclear age again. Nuclear is very popular and in this day, and there's a large drive to have these small modular reactors competing by the year 2030. So what are the challenges we face? Obviously, there are large challenges worldwide in rising energy demand, population growth, economic development, and even the cost of electricity, typically like in Europe and all over the world. There's also the environmental sustainability, moving away from fossil fuels. Typically, South Africa is one of the worst in terms of coal-fired power stations. And then there's also energy equity, regions, developing countries, and people who still do not have access to electricity. So what are the developing world challenges? It's a stable, low-carbon nuclear power that is needed. We also know that the role of solar and wind power is useful and is expanding heavily and dropping in price, but it is overplayed. We install 100 megawatts of solar power. We know that that's available 12 o'clock on a sunny day, but either side of that, we do not have the power that it is rated at. And we know that wind power is there when the wind is blowing. So there are most organizations in our country and in our continent and wherever require a 24/7, 365 baseload power. We also have in particular areas such as the southern part of Africa, we have regional droughts at the moment, which is heavily affecting countries that are reliant on hydro plants. We're thinking here of Zimbabwe, Zambia, and some of the other countries. We also have arid countries such as Namibia and others that require water inland for agriculture and want to pump desalinated water uphill. In our case, we're moving away from coal-fired power stations to a point where we would like to use other forms of energy to replace the coal, and obviously nuclear is playing a big role in this regard. We can also repurpose some of the older power stations, whether they be nuclear, whether they be small coal-fired, etc. And one advantage with these small modular reactors is that you can move the reactor close to where the electrical load consumer is. We have cases in some of the countries in southern Africa where mines operate with a 35 megawatt load equivalent to our unit, and they pay $11 million a month just to generate diesel energy. So you can understand that this type of reactor, within 2.5 years, it can be completely paid off for the mine. There's also potential carbon credits as income, and obviously that's a consideration when we do our feasibility studies. The leveraging that we are allowing is 30 years of experience in the pebble bed modular reactor device. And this reactor that we are developing is obviously completely next generation, generation 4, and it is designed for these global energy challenges that we are facing. So we're developing this legacy. We have this compact, innovative design. We are the Gen 4 leaders, basically, in the world in terms of development, as the PBMR or pebble bed modular reactor was the leading force in the world until a few years ago. We don't need a large water body, as I've mentioned before. We have a high output temperature of 750, and we have a scalability. In other words, we can add 4 units or 8 units, whatever the requirement. And obviously, as you add more units, the cost actually drops because you only need 1 control room. You need 1 administration building. You need 1 maintenance workshop, etc., 1 security force. And from there, we also have a unique triso fuel. This fuel is basically the size of a tennis ball. It has a graphite coating. It can withstand high temperatures under test conditions up to 2000 degrees. It has been uniquely developed in South Africa and exported this design even to other countries so far in different variants. And each particle within this ball is actually coated by silicon carbide. Here you can see that same ball with about 1,800 small particles that are individually coated. And this is how each of those particular particles look with a coating around it. So this forms one of the safety barriers which makes this type of fuel and the reactor a walkaway in terms of any conditions of unsafety. As you can see, the balls on the left are loaded into the reactor. It is fed from the top, and it is taken out the bottom, measured to see what the activity is, and can be added again to the top, or new ones can be added and the spent fuel taken out. The design life of such a reactor is 80 years. Obviously, licensing will be for 40 years, and then 2 times 20 years after that. Even our Coburg reactor is now being qualified for the next 20 years of operation. In conclusion, this is how it typically would look. You can see the radiators here for the cooling, the reactor building. You can see the turbine buildings and all the associated buildings here, the workshops, etc. We also have two designs that we're just doing for architectural purposes. This is a typical desert design for our customers in the Middle East that have asked for a typical layout. And if we look at the more rural bushveld area in the rest of Africa, we are talking typically a design of this type of nature. It's just an artist impression, and obviously it can vary a lot depending on the client's design. Finally, thank you for the opportunity to engage with you, and I'm looking forward to the questions and answer session. Thank you.
Thank you, Professor Mellet. I hope I pronounced correctly your name. I was told that the T at the end must be pronounced.
It's fine. It's no problem. It depends whether you're speaking in French, English, or Afrikaans. You know?
I'm speaking Italian, so no problem.
But I'm not a professor, I might just say that.
I hope you can stay for the next 2 to 3 speakers for the Q&A period afterwards. So this was Professor Dr. Francois Mellet, who is Director of Operations at Stratek Global in South Africa. And for those who just connected, you are watching the third panel of the International Conference of the Schiller Institute, entitled The World on the Brink for a New Piece of Westphalia. Now, I was told that our next speaker, Professor Sergey Pulinets, is on. Is that correct?
Yes, yes, it is correct.
Hello, Sergey. Are you there?
Fine, thank you.
Nice to see you again. After many years, we met in Germany at the conference of the Schiller Institute.
Yes, but from time to time I participate in such meetings. Probably we did not meet during this meeting.
I watched them.
Okay.
So, let me introduce you. We have Professor Sergey Pulinets, who is the principal research scientist at the Space Research Institute of the Russian Academy of Sciences in Russia. So, Sergey, what are you going to talk to us about what today?
Okay. I was asked to speak about what I'm doing in science. And during more or less last 2 decades, I'm working on the problem of the earthquakes forecast. And this problem is not resolved for more or less almost 2 centuries. The problem is that it is monopolized by seismologists who state that short-term forecast of the earthquake is impossible. The main technology they use, it is a statistical processing of the raw of seismic events and statistically processing their distribution. They make conclusion what may happen in future. It may be quite successful for the long-term prediction, but does not work for the short term. I am not a seismologist. I am a space physicist, and starting from the 19th, we observed from the satellites some anomalies which appeared before the earthquakes. And all this time I was working on the problem how to explain the generation of this phenomena. And I would like to show you a few slides. Wait a moment. Is it okay? Yes,
Okay.
do you see?
Yes.
Yes, okay. And my main task was explain the physics of this. Let's look how it will. Okay. In general, the earthquakes happen due to the movements of the tectonic plates. In the first presentation, you have seen the ancient state of our planet. Now we have several large tectonic plates which are moving in different directions, and during their collisions, they create the strain, stress, and when it reaches some limits, the break happened, and this is the earthquake, the movement of the tectonic or blocks in the fault could be different, and they have different names: thrust faulting, normal faulting, strike slip. For example, strike slip, it is what we have in California, and subduction zones, it is thrust, reverse thrust, or normal faulting, when one tectonic plates subducts under another one. But going back to the physics, there were in 19th the works both of the Russian and American seismologists showing that there appear some anomalies in the areas of the earthquake preparation, of the velocity of propagation of seismic waves, emanation of different gases, and changes of the level of the groundwater, and so on, so on. And one of the interesting things, it is emanation of radon. Why it is interesting? Because its behavior, and here is behavior of different physical parameters before the earthquakes. This is a radon emanation between previous and next earthquakes. And we see its behavior, it increases and then drops after the earthquake. And the different theories left, it is American one, right, it is Russian one, show that it works. What is interesting with radon? Radon is radioactive. It emits the so-called alpha particles. Alpha particles, it is a nuclear of the helium. It is a gas of our atmosphere. It has 2 protons and 2 neutrons. And this particle is very energetic. It is 6 mega electron volts. So entering to the atmosphere, it starts to ionize the near ground layer of atmosphere. And we see the connection of the Earth's deformation with the emission of the radon. This picture is very interesting in the sense that it is a water reservoir. And during filling and emptying of this reservoir, the stress was changing, and we see the strong variations of radon. So it is connected with the strain and stress in the Earth's crust. And it was demonstrated by many cases that this is before the Kobe earthquake. You see the strong increase of the radon flux. I will not stop deeply on this physics, show only one thing, that when the energetic particles enters with the neutral particle or the particle of the gas, it removes the electrons and forms the positive ion, and the electrons are attached to the neutral particle and forms the negative ion, and these ions are the water vapor which exists in the atmosphere becomes to be attached to these ions because molecules of water are polarized. The oxygen atom, it is a negative polus of the dipole, and hydrogen atoms are positive. So the water molecules are attached to the positive ion by the atom of oxygen, and to the negative ions by atoms of the hydrogen. And by this way, there are formed the large cluster ions, because more and more water molecules are attached to the ions, and this changes the conductivity, electric conductivity in near ground layer of atmosphere. It is one consequence of this, and another one, during attachment, this attachment is more or less the same as condensation. And during condensation, the latent heat is released by the water molecule. So we have two main consequences of this. Wait a moment. It does not move. It's too much of slides. I don't want to go. Two main consequences. What are these consequences? During formation of these large cluster ions, latent heat is released, and quantity of this heat is so large that it is able to change the air temperature in the region of the earthquake preparation. And during this process, we remove the water vapor from the atmosphere. So simultaneously with the increase of the temperature, we will observe the drop of air humidity, and we will see, and we are able to see from the satellites the thermal anomalies which appears in the area of earthquake propagation. At the same time, because these large particles cannot fastly move, their mobility drop, so the electric conductivity drops, and in the global electric circuit, the potential of the ionosphere is this ionized layer of our atmosphere, which starts from the 60 kilometers up to several thousand of kilometers. There appears anomalies in the ionosphere, which are connected with the changes of the ionospheric potential. So two main consequences, the thermal anomalies, ionospheric anomalies, which we are able to register with the satellite. And just I am working on the space physics, and we are doing this satellite monitoring, and I will show you some examples of this. Wait a moment. Here is this is one of the earthquakes near border of Chile. This is a Chile. It is a Pacific Ocean, and you can see the increase of air temperature, decrease of the relative humidity, and it is one cannot imagine that in open ocean the humidity drops up to 2%, which is in natural conditions is absolutely impossible. And now I will try to show you how this develops. This is some parameter which we call the atmospheric chemical potential. I will not go deeply what is this. It is calculated from the air temperature and humidity. And you can see how every 3 hours, this is a special distribution of this parameter. And you will see with approaching of the earthquake, you will see the strong anomaly which is forming around the epicenter of this earthquake. Here it is a maximum. So, and these anomalies appear several days before the earthquake. And by this way, we are able to make a short-term forecast of the earthquake. I can show you many cases of this, but I will go to the conclusions. We are in the system which is non-equilibrium, non-linear system, where we deal with the transformation of energy from the mechanical to the chemical to the thermal to electrical, and all these things we are able to follow up and to register the short-term precursors of the earthquakes. What is the problem? The big problem is that this is monopolized by seismologists. They do not want to walk in this direction. Up to today, they claim that prediction is impossible. It doesn't work. And okay, we can follow these short-term precursors globally, but we are several people. We cannot make the global monitoring, and the forecast will be possible only when the state itself will create the service like emergency, like the firemen and so on. It should be a special service of the earthquake prediction. And seismologists say that prediction will be possible in future. It will not be possible in future because in no institute, no college, there is no such subject like earthquake forecast. We do not teach young people. If, for example, I am not young, will I disappear? I'm not sure that somebody will continue with this research. So this is a problem which we are fighting, and I hope we will find some solution of this problem. Thank you very much. Okay.
Thank you. Can we have the full screen again?
Yes. How to stop it?
Well, I go on while you try to solve it. For those who connect right now, we are at the third session of the International Schiller Institute Conference, The World on the Brink for a New Piece of Westphalia. And we just heard Professor Sergey Pulinets, who is the principal research scientist at the Space Research Institute of the Russian Academy of Sciences, talking about research into forecasting earthquakes. Now, the next speaker is Professor Gennady Aksenov from the Vavilov Institute for the History of Science and Technology of the Russian Academy of Sciences, Department of the History of Earth Sciences. And but he will be introduced by my colleague William Jones, who is the IR correspondent in Washington, because of the specific subject of his presentation, which is Vladimir Vernadsky and the Eternity of Life. So Bill, who is also a scholar of Vernadsky, will introduce Professor Aksenov to us. Hello, Bill.
Okay. Hi, Claudio. Thank you very much. Gennady Aksenov, who will be speaking here, is not here in person, but he has given us a video which was presented last year at the Russian Cultural Center on the occasion of the 160th anniversary of the birth of Vladimir Vernadsky. Gennady, Professor Aksenov, has been involved in Vernadsky work for most of his life. He has written many books on Vernadsky, including a major biography, and he has spoken in many international fora on the work and the importance of Vernadsky for global science. Unfortunately, Russian science has not been always taken as seriously here in the United States. We know who Dmitry Mendeleev is because we wouldn't have the chemical elements in their present order without him. Vernadsky is less known. There are books that have been published by him, the Biosphere in particular, which Mark McMenamin had edited the most important translation of that work some years ago, and a small work on the issue of geochemistry. Russian science has always been extremely important. Today, there is no science attaché at the Russian embassy because in terms of delinking, the attempt to delink from Russia, we've also delinked from Russian science. Some people probably think that that's not so important, although they underestimate the actual significance of Russian science in the global science community. I'll just point out that without people like Sergey Korolyov, who was a young engineer following in the footsteps of Konstantin Tsiolkovsky, who probably was the earliest person who laid out a framework for us getting into space in 1903, 1904, got the first satellite in motion and sent the first man into orbit. That was the entry of the space age, thanks to Russian science. Vernadsky, although he is not so well known, is probably one of the most creative scientists worldwide in the last century. He was Russian-Ukrainian. He was born in St. Petersburg, but his parents were both natives of Kiev. And as a young man, when his father, because of illness, lost his position at at St. Petersburg University, they returned to Kharkiv, or Kharkov as it used to be called, where Vernadsky grew up. So he was well acquainted with the situation in Ukraine and was also committed to the development of that region, which then was a part of the Russian Empire. At a certain point in his career, Vernadsky had served in the Imperial Russia. When the empire disappeared, he was a member of the Russian Duma, responsible for education. And when the Bolsheviks took over, Vernadsky, as a member of the Cadet Constitutional Democratic Party, went to Ukraine, fearful of imprisonment, where he created the Ukrainian Academy of Sciences and the Ukrainian National Library, which is still named after him. They haven't gotten rid of him, although he was a Russian-Ukrainian. Russian was his native language. This is how he taught. That was the language he used to write his great works. But they haven't gotten rid of him because I think if they did that, that would be the end of Ukrainian science. And hopefully it will be a unifying figure at the point where we have come over this war through some kind of negotiation, that he will help to bring together these two peoples who have been connected throughout their history. He helped create geochemistry at the beginning of the century. He founded the science of biogeochemistry. He also was the person who instituted nuclear science in Russia in 1910. At a very early stage, he wrote a paper in which he encouraged the Russian government to look for uranium because nuclear power was going to be the wave of the future. He knew that through his contacts, personal contacts with Marie Curie in Paris, with whom he had worked, with Otto Hahn and Lisa Meitner, whom he also knew personally. In addition, he worked in the area of meteorology. He introduced radioactive tracing for determining the age of ancient material. And as Lyndon LaRouche had always said, who was fondly promoting the work of Vernadsky, that Vernadsky's division of the world into the three parts, one was inert matter, the second was living matter, and the third, on top of living matter, was the world of the mind. Vernadsky's idea saw that these were all different states of space, although interlinked, in many respects independent. What Professor Aksenov be talking about is the notion of life, kind of a unique notion that Vernadsky had in forming the science of biogeochemistry. But more importantly, he founded the science of ecology as a science of man operating in the living matter to make it more productive, to develop it, and to give it a higher power through the activity of man, which based on the notion of reason, based on the creative discoveries of man, understanding in an ever greater sense the laws of nature, is able to intervene and to make it into a more productive force. Vernadsky's idea was that the mind of man was indeed a geological force in the changes that it brings into nature. The paradigm for that, of course, is turning the desert into a garden, as we have seen in the most extensive example in northern China, which the Chinese are doing today, is a prime example of how man, through his own activity, changes nature, making it more productive. The signal event for that is the ability of man to increase the population, potential population density from the time of the Pleistocene, where we had probably a population potential of probably several hundreds of thousands, to where we are now at the point of 6, 7, and more billion people. So Vernadsky emphasized that this was the role of man in the universe, utilizing what Mr. LaRouche talked about at the beginning, the notion of creativity, in order to advance the world of man and the world of the biosphere through his own creative innovations. So I will, with that, leave you with Professor Aksenov, who will talk about the notion of life and the eternity of life, which was a thesis of Vernadsky that he held throughout his life, which still has to be discussed and to be understood by the world of science.
Thank you, Bill, but I think we have a problem because I'm told that we have no video of Professor Aksenov.
Yes, we should. I sent that to Dave. Dave,
He is listening to us, of course. He told me we have no video. Dave, could we solve this in a very short time? Otherwise, we would start the question and answers, and then later on we would show the video.
I could do that. I can get you. Okay.
I get no answer from David. Okay, so you send the video, please, Bill, and then David, please, can you bring all the speakers for us all together? Okay, there we are. Does any of you has any question on the presentations we heard? Like Dr. Mellet, you have a question to Professor Pulinets or vice versa? Or to Bill? Otherwise, I have a few questions here already. So, but I have a question from actually for both of you, for Dr. Mellet and Professor Pulinets. So let me start with Dr. Mellet. When you said thorium can be, when you said thorium can be used as a fuel, does it have to undergo conversion? That was the question. And Sergey, do you want the question now? It's, well, have you developed or picked up any possible reverberation or resonance throughout other solar system bodies that may be part of developing these precursors? So these are the first two questions, and please, Dr. Mellet first.
Yes, thorium, we have very rich thorium deposits in South Africa, in the mine in the Western Cape. And the general conclusion on that is that as long as we have uranium available, it would just be, easier to work with uranium right now than thorium. So those deposits are mined and kept as stock, but is not utilized at the present moment in reactors, although it can be used and so forth. Another interesting development worldwide is that the spent fuel from reactors is now being considered for further utilization. For example, in the USA, there's a calculation that there might be 500 years worth of uranium just in the spent fuel. And in Europe, it's actually believed to be twice that. In other words, for another 1,000 years. So when we look at the uranium then from that perspective and the retreatment of the unused fuel, although it's highly active, that presents a case for utilizing that fuel rather than going to thorium right now. And that is about the science at the moment.
Thank you. Let's move to Professor Pulinets. Did you get the question? Should I repeat it? You have to unmute yourself. You are muted.
Yes. Okay. The problem of gravitational resonance is a subject of very hot discussions because, physically speaking, the gravitational forces from other planets of the solar system are very weak to create something like deformation of the Earth's crust. So if you will talk about this in academy, they will blame you that you are astrologist and so on. So trying to interpret the positions of the planets into the case of prediction of the earthquakes. Nevertheless, there are some works which show some connection of this. So in present moment, it is difficult to say because there is no clear explanation of this effect.
Okay, thank you, Sergey. This was a question from Cal Smith. He also asks whether it is possible to receive your slides because he wants to work with them among US universities.
You want to I share my presentation, yes?
Yes, you can send it to us and then we can give it to
I will send them to you. Okay, no problem.
Okay, very good.
To whom I contact with Rick Sanders, I probably send to him, okay?
That's not the wrong address. Okay, and then we should go, do you agree, Bill? We should go and watch the video with Professor Aksenov, whom I repeat, he is from the Vavilov Institute for the History of Science and Technology of the Russian Academy of Sciences, Department of the History of Earth Sciences. The title of this presentation is Vladimir Vernadsky and the Eternity of Life.
Уважаемые коллеги, хочу в этот год 160-летия Вернадского поблагодарить наших американских коллег за возможность выступить и рассказать о нем, о его главной идее, которая, к чему посвящен мой доклад, а также Россотрудничеству в Вашингтоне и неправительственный экологический фонд имени Вернадского, который вот в этом году издал мою книгу «3 биографии Владимира Ивановича Вернадского». Мой доклад посвящен главной идее Вернадского, которая, к сожалению, еще не освоена мировой наукой. Вернадский такой универсальный ученый, и в то же время у него есть как бы своя задушевная, важнейшая для него, определяющая всю его научную деятельность, идея, которую кратко можно обозначить так: идея вечности жизни. И все, начиная с 1921 года и кончая концом его научной деятельности, эта идея его одушевляла, и он превратил идею в научную концепцию. Вот что важно. Началось все с 1921 года, когда он, приехав с юга России, времен Гражданской войны, обнародовал эту идею в докладе, который назывался «Начало и вечность жизни». Здесь он обозрел, его доклад направлен, во-первых, против распространенной, которой мы все поглощены этой идеей, происхождения жизни, что жизнь не случайно на Земле появилась в результате стечения счастливых обстоятельств. Вернадский выступает против этого. Жизнь не случайна. Он обозрел все факты, которые в течение 500 почти что лет ученые пытались найти тот момент, когда из мертвой материи появилась живая материя. И он такого момента не нашел. И считал, что вот принцип биогенеза, то есть происхождение живого от живого, который обнародовал в 1668 году, который он называл «Великий год в истории науки», принцип Реди. Живое происходит только от живого. И поэтому начала жизни нет. Вот он и писал в этой статье. Было ли когда-нибудь и где-нибудь начало жизни и живого, или жизни и живой такие же вечные основы космоса, какими являются материя и энергия? Жизнь вечна постольку, утверждает он, поскольку вечен космос и передавалось всегда биогенезом. То, что верно для десятков и сотен миллионов лет, протекших от архейской эры и до наших дней, верно и для всего бесчисленного хода времени космических периодов истории Земли, верно и для всей Вселенной. Вот эта вот декларация Вернадский в течение всей оставшейся ему 20 лет жизни превратил в концепцию, в научное доказательство этой идеи. В 1926 году он опубликовал свою книгу «Биосфера». Вот здесь на слайде книга 1997 года, замечательнейшее издание, изданное в Нью-Йорке в 1997 году. И здесь, в параграфе 17, он опубликовал те постулаты, на которых основывается новая наука биогеохимия и учение о биосфере. И тут важнейшие из них, вот эти вот три, которые здесь выделены. Первое. Никогда не было и нет никаких следов абиогенеза, то есть происхождения живого из неживого. Второе. Нет безжизненных геологических эпох. Третье. Живое вещество контролирует химическое состояние среды на всем протяжении геологической истории. В геологии принято, что до Кембрия жизни не было с самого начала геологии, потому что никаких остатков живого там нет. Вернадский доказал, что остатков и не может быть, потому что эта биосфера бактериальная, а бактерии, они не умирают, они остаются в слоях Земли. Они все время остаются в самой биосфере только, и они создают биосферу. И одно из важнейших доказательств Вернадский ввел в 1929 году понятие биологического времени. Значит, новая и фундаментальная наука всегда верна, когда мы обращаемся к понятию времени. Так вот, Вернадский ввел это понятие биологического времени. Время имеет биологическую природу. Время, никакого другого времени. Это вот парадоксальная, казалось бы, мысль, что мы привыкли как будто бы или не обращаем внимания, не доказываем никогда, что такое время. Понимаем, что такое время, как бы, и все. Еще Августин Блаженный сказал, что когда я понимаю, что такое время, но когда меня об этом спрашивают, я никогда не могу сказать, что оно такое. Так вот, время имеет биологическую природу, так как считал его предшественник Анри Бергсон. Но самое важное из доказательств появилось, когда нашли способ определения возраста горных пород. Это очень точная вещь. В течение этого геологического времени или атомного времени, то есть атомное время – это часы, это не источник времени, это не генератор времени, а это счетчик, такие же, как наши обыкновенные часы любого вида. Так вот, и когда это появилось, вот это вот способы определения возраста горных пород, то для Вернадского это было важнейшее открытие. В этом состояла революция для него, революция научная начала века. Время, когда же время стартует, так сказать? Вот он нашел в своих работах, что время стартует в биосфере. Мы-то считаем, что оно начинается как бы время тогда, когда появилась сама Земля, Вселенная и так далее. Для Вернадского это не научное, не доказательство. Потому что он считал, что возраст Земли – это понятие, которое вышло из, собственно говоря, из религиозных, из метафизических понятий, из первой страницы Библии, короче говоря. И вот он писал, если действительно в древнем архее мы наблюдаем начало зарождения биосферы, мы можем принять его за нулевую точку геологического времени. То есть ноль геологического времени находится в биосфере и не где-нибудь, потому что в биосфере, биосфере, продукт биосферы – это осадочные породы, которые образуются в море, они там осаждаются, уплотняются все больше и больше, опускаясь вниз, вернее, наоборот, что наслаивается сверху, а внизу это все уплотняется до метаморфического слоя. И вот в этом метаморфическом слое породы успокаиваются, и здесь начинается отсчет, тот, который считают по биометрическим способом определения возраста. Вот этот круговорот, потом куски этой метаморфических пород мы находим на поверхности в результате, которые выходят на поверхность в результате тектонических движений, вулканизма и так далее, и определяем возраст. Вот, допустим, породе 3,8 миллиарда лет или 4,4 миллиарда лет. Так вот, это начало его отсчета начинается в биосфере. Биосфера всегда молода, а выходящие из нее породы имеют самый разнообразный возраст, и все они начинаются в биосфере. Вот это вот важнейшее доказательство, которое нашел Вернадский. Мы теперь мы обращаемся к современности. доказана эта идея или нет? Доказано в результате развития науки на современных данных. Вот одним из первых, кто сделал такую важнейшую работу, это микробиолог, академик Юрий Александрович Заварзин. Он описал биосферу архея, вот ту самую, которую Вернадский считал, что там начинается время в биосфере. Вернее, оно начинается во всех геологические эпохи в биосфере, вот, а не в каком-то мифическом формировании Земли. Вот что писал Заварзин. Существенно, что прокариотная система самодостаточна и для поддержания собственного существования в течение неопределенно долгого времени, а фактически в течение всей геологической истории Земли. Он доказал это фактами микробиологической экологии. И Вернадский считал, что бактерии выполняют все функции биосферы, то есть фактически это что означает? Что биосфера может состоять и состоит из одних бактерий. Бактерии – важнейший состав живого вещества. Теперь, значит, бактериальная биосфера доказана, что она существовала на протяжении всей геологической истории Земли. Вот. Это было доказано в микробиологии, а вот совсем недавно это доказано просто в геологии. Профессор Джон Велли, американский геолог, писал: «Сегодня открытие минерала циркона дают основания полагать, что Земля остыла гораздо раньше, возможно, уже 4,4 миллиарда лет назад». Значит, почему он так написал, что она остыла гораздо раньше? Потому что это общая установка нашего сознания, что Земля была раскаленной, сухой. На самом деле она никогда не была раскаленной и сухой. И вот открытие минерала циркона это доказало. Минерал циркон образуется только в водной среде и в прохладных условиях. Еще одно доказательство появилось на Кольской сверхглубокой скважине. На глубине 8 километров нашли анаэробные бактерии, которые, когда их достают, они мгновенно замирают, потому что они не могут дышать в кислородном воздухе. Породы там пористые, пронизаны трещинами и волосяной водой и газами. Вот биолог Галанин считает, что существует литобиосфера Земли. Это гигантский слой, мы не знаем толщины его. Это настоящая подлинная биосфера. И, собственно говоря, она занимает больше 90% всей биомассы Земли. Вот такая мощность этой биосферы, фундаментальной биосферы. Так вот, и уже в наше время, естественно, происходит освоение Солнечной системы, инструментальное исследование ее, и НАСА уже поставила главной своей задачей, и программа разрабатывается, поиск жизни в космосе. И возникла наука астробиологии, но она в плену находится идеей происхождения жизни, то есть ее случайности. И когда находятся какие-нибудь следы, например, абсолютно точно относятся к живому веществу аминокислоты или хиральное вещество, левое, биологические биосферное вещество состоит только из левого вещества. И здесь мы теперь обращаемся к главному выводу Вернадского, что биосфера геологически вечна. Вот правильно говорить не жизнь вечна, а биосфера геологически вечна. Вот точное научное определение. И биогеохимия, которую он создал, она должна быть базовой дисциплиной для создания теоретической основы всех наук о Земле. И когда это очень трудно понять, вот эту вот вечную жизнь. Я там сам долго привыкал. Зато когда я привык к этой мысли, оказалось, что все научные факты легко укладываются и создается непротиворечивая картина мира. И нам еще предстоит ее освоить. В том числе и понятие о разуме как геологической силе и космическом явлении. Подробности можно посмотреть, найти в моей последней книге, которая она продается на Озоне, вот это на русском языке, а на французском она издана в городе Бордо, вот по этому вот адресу, который здесь приведен, и она находится в свободном доступе, за чтение ее платить не нужно. Спасибо за внимание, дорогие коллеги.
Well, that was a great presentation by Professor Aksenov, who is unfortunately not with us today. So we have a question concerning this presentation, which is actually addressed to all of you. Before reading the question, let me remind to everyone who just connected to us that this is the third panel of the International Schiller Institute conference entitled "The World on the Brink for a New Peace of Westphalia." And this is a scientific panel. No. Now, we have a question from Robert Castle, who is a young member of the Schiller Institute. And he says, it is quite fascinating to note how Vernadsky's ontological concept of biogeochemistry and his epistemological concept of the eternity of life both subsume all of the presenters' ideas in different ways. Does anyone on the panel know of any international efforts to organize a community of scientists to put forward the great genius of Vernadsky as a figure of Russian-Ukrainian reconciliation? If no, can such a process be initiated as a continuation of the work of his panel, of this panel? So, I think, Bill, this is addressed to you. You want to answer?
Dr. Pulinets may want to have something to say on this himself. I'll just mention that I think it is extremely important. We don't see the way out there, but obviously at a point where there's going to have to be some kind of a reconstruction of Ukraine, and I can only see that actually happening effectively if there is also some kind of real peace negotiation that has been created. The issue of Ukrainian science becomes also very important. What's happening in Russia is, I think, and Dr. Pulinets can talk on this too, is a revival of Vernadsky's ideas during World War I, when Russia was totally isolated in terms of international trade. Vernadsky created an institution to go around to examine the raw materials that existed in the country in order to create their own internal resources when the resources of the world were restricted to them. The same thing is happening, as I understand, especially in the Russian Academy of Sciences, on the issue of geophysics, which is playing a major role now, in a similar way that Vernadsky had done earlier, of utilizing the tremendous natural resources of Russia in order to create economic growth for them and also to give a great contribution to the world. So I think this is happening in terms of the Ukrainian situation. It's going to take a longer period, but I think the role of Vernadsky at a point in time where there is a coming together more and more between Russia and Ukraine would be playing a major role.
Thank you, Bill. Sergey, you want to add something?
I can add something about the role of Vernadsky in study of radioactivity, because he created the Radium Institute in Leningrad, now St. Petersburg. He was first, it was told that attracted attention of the government to the importance of the nuclear energy. And he was the initiator of the commission, which later was working on the creation of the Russian atomic bomb. But because he passed away in 43rd or 44, 45, yes. So he only started this work and then it was continued without him. But he understood the importance of this thing. And another idea of Vernadsky, it is, as he called gaseous bracing of the Earth. That Earth is emitting a lot of gases, including radon. And these two ideas, Vernadsky natural radioactivity and gas braces, were some fundamental things which are used in our theory of the generation of earthquake precursors. So I wanted that something from his interest, which were not only the biology, but other things as well.
Sergey. So we have more questions. We have one question for Dr. Mellet, then another question for you, Sergey. First, from one viewer who asks, what are floating reactors? And I will add, can you explain to us not only what they are, but what the advantages are, what the disadvantages, whether there are already floating reactors in the world?
Okay.
This is for Dr. Mellet. And for you, Sergey, now comes the question for you. This comes from my colleague Marcia Merritt Baker. And she says the following, and also for you, Dr. Mellet, if you want to answer to this afterwards. The controlled media assert that there are more earthquakes today, as well as more every extreme environmental event. There are more typhoons, more droughts, more floods, more everything. This is for the purpose of blaming everything on climate change caused by human activity. But what is the real situation with patterns and frequency of earthquakes at present? If you have any evaluation on that. So, Sergey, think about it. And first, I want to have Dr. Mellet. Please unmute yourself.
Yeah. Yes, apologies. When we talk about floating reactors, in the SMR world, there's only 2 floating reactors on a barge in Russia, and those are actually submarine reactors of the old type that are utilized and called SMRs. But in actual fact, the design is very old and doesn't really fall under SMR class in terms of safety and things like that. So from that perspective, those are the only ones we know about. We know there is further development that people are looking at, but there's nothing that's operating right now. Those 2 reactors are actually operating in a harbor in Russia. The ones I talked about, there's 2 of them. And they are supplying power to that harbor. That's well known. Like I said, submarine reactors.
Okay, thank you.
May I add something about floating reactors? It is important now for the development of the northern areas of the Russia, because to create the infrastructure through the earth, it is very difficult. So Russia now uses the floating reactors coming along the northern oceans and supply the cities which are in the northern border of the Russia. So now there are one working, and it supplies by electric energy by the whole city. And Russia plans to put along the northern border several floating reactors. It is the fastest way to bring the energy to these cities in the northern Russia.
That's correct.
Thank you. Sergey, you want to answer the other question? About
about the growing number of catastrophic events, and specifically the earthquakes. It is not so the only increase of the seismic activity was observed after the nuclear tests in 50s and 60s. There was some increase of seismic activity on our planet. But after that, it is more or less the same level.
Dr. Mellet, you have an answer to this?
But about another events, okay, we have climate change, which is it is not proved that is anthropogenic, but we observe some changes in our environment, and because of increase in temperature, we have increased number of water in the atmosphere, which is source of hurricanes and other atmospheric events. And yes, we have increase of this atmospheric emergencies. For example, in Russia, we have increase of the how to say, not typhoons, as smaller events. How they know. I forgot the word. Sorry.
Okay.
So, but yes, tornadoes, yes, tornadoes we have increased, and in some areas where they never were observed in Russia, they now appear. Yes, and the precipitation, especially in this year, they are very strong, and in many cities of Russia we had extremely precipitation, and just last days, including Moscow. That's all what I can say.
You want to add something?
Yes. If one looks at the Fukushima incident particularly, or the accident rather, we see that the conditions worsened over time, and the design was literally for 2 stories of water to pass through. It allowed for that. But due to the changes in the tectonic plates and whatever, eventually there was a tsunami which was 3 stories high. So that was higher than what the design allowed for. And we saw the effect of that and the damage. The fortunate thing is we didn't lose one life because of that nuclear accident. It was mainly due to the tsunami that life was lost in Japan. And I was actually there right after the event to assist with some of the recuperation of electrical power. When we look at, for example, just last week, I looked at the seismic events, because the Kuburg nuclear power station was the first power station in the world to have a raft, a seismic raft, below the power station, below the nuclear island. It consists of about 470 pillars with neoprene rubber on top, and then a lead bronze plate, which allowed up to 7 on the Richter scale in case there would be an earthquake. Now, that was based on an earthquake that hit in 1974, South Africa, and was about on 6.4 on the Richter scale. So they decided to, for the first time in the world, for a nuclear plant, to build a seismic raft with the French. And we looked at the figures since then. What has happened over time, over the last 40 years, in terms of the licensing for the next 20 years. And actually, none of the events actually surpassed higher than about 3.5 on the Richter scale over the last 40 years. So, whereas we think that things are actually increasing, the frequency might be higher, but the magnitude is actually not higher than what we've had before. But one has to do all the considerations for the new nuclear plant, where it is located, are there tectonic plates close to it? We've got some new nuclear sites in South Africa where we have to consider these close tectonic plates and the effect over time. So from that point of view, in our feasibility studies, we have to include this all the time. I hope that sort of answers from that point of view.
Let me add something here, Claudio, on this stuff. That obviously a lot of things are going on. We see the tornadoes here in the United States that are much more extensive. Weather is much more extreme. But at the same time, we see that there's a tremendous amount of unusual solar activity. And of course, these things are connected, that the sun has an important role to play here on Earth. And at the moment, there's not much we can do about this. And so if we try and cut our consumption, or if we try and, save on electricity, this is not going to help. The only thing that we can do in the long term is that we really have to go quickly out to space to begin to try and figure out what is actually going on out there. And all the measures that we're taking now, in particular with, limiting, at what Lynn talked about, the issue is still there today, the lack of creativity. How do you increase that? How do we get things moving in the direction which we have more scientists, where we do more work in terms of understanding how nature, how the universe around us is important. And I think Vernadsky is important there because he was also a planetary scientist. His last work was the chemical structure of the biosphere and its environment. And he was looking at the Earth from a planetary point of view. But we have to do certain things. I mean, and cutting off science and refusing to work with the Russians on scientific development, these are the things which are going to cause the biggest problems for us than anything else that we can do. And we better get moving quickly in order to get a better handle on how this universe is working, because that's our only way out, using the human mind to understand the world in which we live, which is rapidly changing, in order to be able to intervene effectively in it. That's the key.
I agree with you, Bill, and let me add that the question of the origin of climate change. First of all, climate change has always been there. It's not something that we have discovered. It's always been there. And last year, a group of Italian scientists published a book called Dialogues on Climate, and several parts of this book were dedicated to demonstrate the correlation between the sun activity and the climate patterns. I must add that one chapter was also dedicated to the issue of extreme weather patterns. And the professor of the University of Milan who worked on this, he went to consult all official records. And his conclusion was that the intensity and the number the frequency of extreme events has not changed, has not increased. What has increased is the media reports about
especially magnetic storms. In radio, television, magnetic storms, your health is in danger, and so on.
Yes. Now, this doesn't mean that in some parts of the world you have new phenomena which were unknown, but what happened in other parts of the world? So you have to base your views on data and not, on anecdotes. Unfortunately, what we have today in the media is anecdotes, right? You have one day of flooding, and this is climate change, but then you discover that there was a dam which was obstructed, and that's what caused the catastrophe. Anyway, we have more questions for our distinguished panelists. We have one question from Carl Smith on Vernadsky. Is Vernadsky's view of biological time at all evident in any of NASA's work, NASA, on searching for life? Is NASA still completely dominated by the origin of life, quote unquote, origin of life, random theory? This is the question. And then I have another question to Bill Jones from Ambersmith. How does he foresee the activity of the general public to help to introduce Vernadsky to the general science curriculum in the US? Particularly as the pedagogy is correctly so twisted as it means, how might we overcome the anti-true science, anti-Russia bias? I'm sorry, but there was no punctuation, so I couldn't get it better than this. I hope you understood, Bill.
Yeah.
But as to the first question, who wants to answer the first questions on NASA? If Vernadsky's view of biological time is at all evident in any of NASA's work on searching for life, or whether NASA is still dominated by the theory, the random theory of origin of life, random theory.
Well, look, what I can say is that I don't think the notion of this biological time has been around for quite some time. Vernadsky and other people have mentioned it. I don't think that plays much of a role in what NASA is doing, but I think that the search for life is still very much alive at NASA. The thing is that the notion of the eternity of life is not really accepted by the scientific community. I mean, this abiogenesis, there are all kinds of experiments still going on trying to prove this, but it has never been shown. I mean, life has never been shown coming out of non-life. And this is what Vernadsky was using. It wasn't a religious belief or anything like that. It was simply looking at the facts and trying to determine, what the situation was. And he was working from the work of Pierre Curie was one of them who took up the old thesis that life was left-handed, and when you see, as Aksenov mentioned, when you see left-handed figures, you indicate that there is life. And NASA is looking for these things in the Webb telescope and in other operations of NASA. They're trying to see if there is life elsewhere, and we're getting a lot of good indications that indeed it is elsewhere. And this was also Vernadsky's thesis. But in terms of the specific notion of biological time, as Aksenov talked about, I don't think that was generally accepted. But nobody has come up with another possibility of how to determine time. Except by looking, even when you're looking at ancient fossils and the like, how do we determine when they existed? We have to look at the atomic picture, right, of what was going. We have to look at the nuclear side of things, which allows us to make these determinations. On the second question of introducing, introducing Vernadsky's ideas into the educational system. I think we have a long way to go. I think that the fundamental thing is that we have got to have more stuff of his translated. The largest bulk of Vernadsky's really late theoretical work on this problems of biogeochemistry, which was the thing he was working on at the last part of his life, has been translated largely in 21st century, and I guess earlier in Fusion magazine we did some of these things. But otherwise, this is for most Americans, it's a tabula rasa. They can read The Biosphere, which is a 1929 piece that he wrote at really kind of at the beginning of his intellectual career, but the rest of it is just not known here. And I think that's the key to doing that is trying to find a way of getting more of his works published.
Any other suggestion?
Nope.
If not, I have a question for Sergey Pulinets.
Okay.
Sergey, you certainly followed the earthquake in L'Aquila, Italy, 15 years ago.
Mhm.
And this was interesting because there was a controversy. An earthquake researcher had found an increase in the emissions of radion. And he had warned the authorities about it, about an imminent earthquake. The question is that it seems that he, however, indicated the wrong epicenter. And had the authorities followed his advice, then they would have moved the people closer to the epicenter. Would have been worse. At least this is what was reported. So the question is, how can we get then more precise about the epicenter? What was it really the problem, and how can we solve it?
Okay. First of all, I would like to say that the scientist, he was more engineer, Giuliani. We were the friends. When I first found mentioned in press about that he, with help of Vadal, made prediction of the earthquake in Aquila, and he was prosecuted by Italian not only scientists but
Justice.
Justice, yes. I wrote him, and we established contact, and I visited Aquila 3 times. And we studied this case very carefully, and just after him, I started to study the radon effects more carefully. So, what about the epicenter? He had 4 or 5 radon measurements in the region of Aquila. And from point measurements, it is impossible to find the position of the future epicenter. The only thing is that from these measurements, it is possible to estimate the future magnitude. But we studied the ionospheric and thermal anomalies for this case, and we were able to see the position of its center from the space measurements. So, using our technology, it is possible to detect the position of the future epicenter, but of course, it is not also very precise. It is more or less 50, 100 kilometers. More precisely, it is impossible to find the position of the epicenter, but to reach this precision, it is possible. And I will send you the presentation. I will include the slides showing how we determine the epicenter from our measurements of different types. But we have technology to determine the position of the epicenter.
Are you confident that we will improve this so that one day we can have a practical way of intervening? Because we have to evacuate people, right?
Yes, I'm confident in this, but the problem is that we should work on this. More scientists should work in present moment, I practically have no young scientists working with me. All my colleagues are abroad in United States, in Mexico, and so on. So it should be organized such work to study and to teach people to work with this problem.
Thank you. I actually don't have more questions, so I would. Oh no, just came a question. It's to Dr. Mellet. The Republic of Guinea in West Africa signed a memorandum of understanding with Rosatom for a floating nuclear power plant. The signing took place on sidelines of the St. Petersburg International Economic Forum last week. What do you think? What is going on in this direction in Africa? And your remarks indicate that technologically, these floating plants will have submarine-type nuclear generators, like the academic Lomonosov in Chukotka, ? Any other ideas? This comes from an anonymous questioner.
Yes, it's a very interesting question because we're experiencing across Africa, with the exception of Angola, and I'm talking now Southern Africa particularly, which contributes, I think it's about 13 countries to that, that there's a shortage of power, electrical power. And only Angola seems to be immune to that from that perspective. The thoughts have been over time that certain, can I call it, gas turbines on ships are used. They're from Turkey, which then would anchor in 3 ports, for example, in South Africa, and provide power until power stations can be built. So there is a philosophy in Africa, particularly, that floating power plants are very useful to cover the time gap of design and construction of new power plants. And due to the fact that a lot of the activity is close to the ports where power is needed, etc., and cities, that phenomena is growing. And I just hope from my heart that the technology on these floating nuclear reactors will improve, because we know that when the ships pass the Cape and they have nuclear waste on them, they're not even allowed to dock in ports, okay, because of this. And the chance of something happening to nuclear waste from a release point of view is actually much lower than an operating plant. So one would just hope that the technology would advance in terms of these portable nuclear reactors, and that they will pass to a safer generation, safer type of fuel, safer type of control when things get out of hand in terms of the nuclear reaction. So that's the only comment I can make. I'm not familiar with any advancement on these type of floating reactors, but I can just express my hope that we advance that technology by far, because we know that the old submarine technology is far back. It's probably generation 2, maybe going into generation 3, but it's years old and the technology is far behind.
Thank you. So I think we can start to round up our discussion here, and I would ask a short conclusion from each of you on the whole discussion in this panel. But also, if you followed our panels yesterday, the first and the second panel, we talked about nuclear energy today, but this conference has another problem with the word nuclear, and that is the threat of nuclear war, which is looming. So we dealt with it yesterday in the strategic panel and in the economic panel, how the West, the declining West, does not want to accept the idea of a system of cooperation in the world, a win-win system of relation among nations, but goes inside the old idea of geopolitics. And we are now already in the Third World War, which is being fought in pieces, like the Pope said, and it escalates every day, and the danger of nuclear war is very real. So we need, therefore, to stop this with the idea that we have to negotiate. We have to come to an idea of a new system of relationships in the world, and the development perspective must be there from the beginning. This goes for Ukraine. This goes also for the Middle East, for the conflict between Israel and Palestine. And nuclear energy is the key, because if we want to have development, we must bring in an abundant, safe, and secure in terms of supply form of energy. So if I ask each of you a short conclusion on the basis of what we said today and what I just said.
I will start. Right. I think that the world is obviously energy hungry. I think there's no doubt about that. I think there's a lovely new era of nuclear awakening. For the past 40 years, we've been fighting for nuclear. Now it's virtually in our laps. It's happening. People want it, etc. Just in terms of SMR designs, there's probably 100 SMR designs in the world, of which 50 are active, and probably between 10 and 20 are actually on the reality and on the verge of being practically implemented. This is a very good sign. Obviously, we don't want to confuse it with military nuclear warheads and things like that. And therefore, we have to play it very safe. We have to be sure where the uranium goes and what happens to it, etc. But as I mentioned earlier, the beauty of actually utilizing the X-fuel, which probably exists to a degree of 95% in the waste that we have. If you take the 5% enrichment out, you have 95% of fuel that just acted as a brake in the fuel. And that we can actually utilize now, although it is hot, it's obviously radioactive, but it presents a complete new opportunity in science to be developed. We know that some of it is happening in France. We know that it's being considered in the US. And I think that we can really advance on this. And I trust that when we have our next discussion on one of these, can I call it conferences, that we will just talk about how many plants are running and how we're advancing in terms of the rollout. I believe that is going to happen in the near future.
Thank you. Sergey, it's up to you. Confess, your studies on earthquake forecast, they will be used against the West by you ugly Russians. Is that true?
No, I'm proud that we are working on the problem which is important to total humanity. We do not make differences between the East and West. I have colleagues in the United States, in Italy, in Japan, in Taiwan. We are working together, and never there appeared some problems connected with the politics. The only sad thing was in my relationships with Poland, with which we cooperated for 40 years in space technology. We were friends, we knew our families, children's weddings, and so on. And they, Space Research Center in Warsaw, we ordered to produce electronic blocks for our topside sounders for the satellite constellation to be launched starting from this year. There should be 4 satellites, and they delivered to us 2 instruments, and last 2 they denied and do not contact with us, and it is very negative situation. But it is only one I have up to now. But returning to the prediction, I hope that we will find solution, and even with not too much people, but we are developing, and I hope on the cooperation with China, because they launched the dedicated satellite for the electromagnetic studies of the earthquake precursors, and this year, probably even in July, they will launch the 2nd satellite, and our constellation from 4 satellites. So we will develop the space system which will observe the precursory events from space. According to the nuclear energy, I can say that Russia made breakthrough on this, because we now producing reactors which treats even the nuclear waste. So to zero, we do not have any waste, and from this waste which we have source of energy for hundreds of years. And this technology, I suppose, could be used all over the world, but for this we need to have the normal, peaceful relationships with all countries. So we should fight for peace and establishing the normal relationships in the world.
Thank you, Sergey. And I hope this video of this panel will be watched throughout the world and by as many people as possible in Poland, so that your words could hit their hearts. And so, Bill, please,
Claudio,
to you,
yeah.
the conclusive remarks.
I would agree fully with Sergey on this. Look, if there's not collaboration between sciences from all nations, science will suffer. And as a result, mankind will suffer. If we look at the history of it, go back to Westphalia 1648, what did it lead to? It led to the creation of one of the greatest scientific countries in the world at the time, in France, with the work of Colbert. And what came out of that? This then went to Germany after the French Revolution, with the Alexander von Humboldt, who did most of his work in Paris and then was in Germany and created the Göttingen example, which then in the 19th century was brought to the United States. U.S. science that was used during the Manhattan Project was a result of German science, the science of Gauss and von Humboldt coming to the United States. And now today, what you're going to see, as Sergey mentioned, China, maybe they're taking the ball here. It passes back and forth, but unless there is this collaboration, it will always suffer. Because while the source is the creative mind, there has to be this communication, both to stimulate the thinking of the individuals and to share these thoughts in order to have this ripple effect throughout the entire community. That's what it lives on. And the issue of creativity, of course, which Lynn introduced at the beginning of this panel, I think is absolutely essential, that we have to have the Peace of Westphalia today in order to bring back science to the type of international collaboration in which it will become fruitful.
Thank you, Bill. And with this, we close our panel. It was a great panel with great presentations, great questions, and a great discussion. So thank you to all of you. And let me announce the next panel, which is the conference is not over. The fourth panel is going to start at 6 o'clock p.m. European time, which is 12 p.m. I think in the United States, and this would be on culture. The title of the panel is "The Richness of the Cultures of Humanity and the Coming Golden Renaissance." And you'll find the complete program on the website of the Schiller Institute. So again, thank you to all of you, to the audience, and stay healthy and feisty.
Thank you.
Thank you very much.
Bye-bye.